Okay, I'm going to keep us on time and get us started. And I'm sure more people will join as we get going at the top of the hour. Hi, everyone. My name is Roxanne Carini. I am the Deputy Director of NWES, the Northwest Association of Networked Ocean Observing Systems. And today we are very excited to share with you a presentation by Seth Travis, who is the data manager for the Northwest Environmental Moorings Group based at the Applied Physics Lab at the University of Washington. And Seth is going to give you kind of a two-part tutorial. And after each part, there will be a break for questions. Feel free to use the chat to add your questions as we go along so you don't forget them. You can use the raise hand feature when we get to the question break. I will call on people and try to get everyone's questions answered. If you have any technical difficulties, feel free to message me in the chat. I will be kind of our tech guru running the meeting today. And with that, thank you again for joining, and take it away, Seth.
Great, thank you, Roxanne. So yeah, thanks for joining us today. My name is Seth Travis. I joined the team about a year ago. They brought me in to sort of work to revise some of the data workflow that we have for our orca moorings. One of the main things was to get this ERDDAP set up so that we could have a better way to get the data out to the public. So a rundown of what we'll be looking at today. As Roxanne said, I've split this talk into two halves, sort of recognizing that there's a bit of a wide range of interest in what we're doing. So on the first half, I'll be giving an ERDDAP tutorial. We'll give an overview of our orca moorings program. We'll go over what ERDDAP is, and then we'll demonstrate how to actually access our data from our ERDDAP, showing the different sort of data products we have, and then lastly, some interfaces that we have for that. So that's going to be very functional. Like if you just want to go and get data, the first half is for you. We'll take a break for questions at that point. And then the second half is I'm going to get a little bit into the weeds of our actual data processing workflow, how we go from the raw data that we get to the buoys to each of the levels of data processing that we do on the data, and then finally getting it out to the users. So the Northwest Environmental Moorings Group, we maintain a series of moorings throughout Puget Sound. Some of these moorings have been out there for more than a decade, and so they've been helping with our goal of providing real-time and long-term environmental monitoring. These moorings are called orca buoys. ORCA stands for Oceanic Remote Chemical Analyzers. It consists of a winch-driven system where we have a CTD package on the end of this winch that raises and lowers it throughout the water column. As I said, it contains a CTD as well as some other chemical and optical sensors, such as an oxygen sensor, chlorophyll sensor. We do have some other sensors on it for different package loadups, but those are the main ones. We have 6 buoys out there operational right now. There's the, let's see, we've got the Toano buoy, the Hoodsport buoy, the Hansville buoy, Dabob Bay, Point Wells, and Carr Inlet. For each cast, we're showing here a plot of the sort of data we get from a typical individual cast. So the behavior that you see for the cast is the CTD package stays at a resting depth, typically about 20 meters. We chose that depth to try to minimize some biofouling that can occur over time. And so the package is sitting at the resting depth. We turn everything on. We give it a little time for all of the instruments to get started, everything to just warm up. We then raise the package to the surface. It sits there for a moment for the instruments to equilibrate, and then it performs our downcast, and will be our main section of the cast that we get data from. And then afterwards, it returns to its resting depth. So you can see the typical profiles that we get. This is a profile taken in September at Hood Sport. And this is, the sort of data that we get for every sensor. Each cast samples at 4 Hertz. Some of the old casts, the very old data, it does sample at their lower rate, but right now all of the casts are sampling at 4 Hertz. And the CTD package has a target moving speed of 25 centimeters per second. This means that you end up with a sample taken roughly every 6 centimeters when the package is moving. So for a 100-meter cast, this can result in 1,600 samples for just the downcast portion alone. The amount of data that we have is pretty substantial. So the buoys were deployed at different times. Our oldest one, Tuano, has been out there since 2005. And then we've had some more recent buoys deployed in 2010. But even for the more recent buoys, we have 13 years of data. You can see that for Tuano, we have more than 36,000 individual casts. And then as of September, for the entire set of buoys that we have more than 117,000 individual casts. So as you can see, it's a pretty rich data set. But with all that data, the challenge then becomes, how do we get that out to the public? And so that's why we've turned to using ERDDAP. So what is ERDDAP? ERDDAP really it's a data server platform. And so it can be very useful for distributing data, but it also has tools that can be helpful for visualizing data. It allows for temporal and spatial subsetting of the data. You can download the data in multiple different data file formats. So that's really useful for the different audiences that your data may be trying to get to, that may want NetCDFs versus CSVs versus MATLAB files. So that feature is really helpful. There's also visualization tools. You can explore the data on the website, and then you can also save the resulting images. So if you just need a quick plot of some of the data, this is a really helpful way to go in and just get a quick and dirty way of getting some data. And then lastly, the server is called RESTful, meaning that the URL that you use to download the data contains all of the information that you need to access the data. So in the URL, it would have whatever subset of data or whatever constraints that you put on it. And so just by manipulating that URL, you can change which data you're downloading. But overall, ERDDAP is a great platform for users to directly interface with the data, explore it, and see what they want. But it also has features that make it pretty useful for some automated machine access of the data. A resource that I found, which I think is very useful, especially if you're not familiar with it at all, is this Coast Watch ERDDAP tutorial. I'll leave it here for a second, but I believe we will be distributing part of this PowerPoint later, and I certainly would recommend it if this is something that you think you're going to be using more frequently. But beyond that, so how do we actually go in and start using the ERDDAP system? Here I'm going to show you part of our web interface. I'm just going to walk through some pieces of it first, but then I'm actually going to get out of this PowerPoint presentation and go to our website and show you how to actually use the system. For the web interface, this is our front page of our NWEM ERDDAP. You can see that it's got a description of the NWEM program on the front. It has a link to our data manual, which we are working on getting it set up now. There's a pretty good draft, but it is available for people to check out. And then lastly, the access to the data sets themselves. And you can see the URL for our ERDDAP down here as well. When you click on this, the view a list of all of the data sets, it takes you to this list. This is a useful way for exploring the different data products that we might have. We've only got 72, which may sound like a lot, but there are some ERDDAPs with a few thousand. So in that case, it might be more useful to search for what you're looking for. But for our purposes, I usually just go and click and scroll to the data product I want. You can identify these by the title, which will give a brief description of the different products that we have. And then there's also the data set ID. These are unique for each ERDDAP product and can be useful for automated machine accessing of the data. On the left, you see the data access forms. There's different forms depending on the type of data set there is. So there's these two types. There's the table DAP and the grid DAP, and you see that they aren't available for every data product. This has to do with how the data is structured. And that part of that is determined by the ERDDAP data manager when they create the data and then put it up on the server. But a brief sort of overview of the difference. A table DAP, it's really just a list of points with values associated for each of those points. You can basically think of it like an Excel table or a CSV file, something like that. And then you have grid DAP. These are variables on a fixed data grid. So they have access variables. I like to think of a good example is, maps or time series of sea surface temperature, where you would have, an X, Y coordinate for every point. The variables, the access variables can, again, be whatever you define them to be. Beyond the direct data access forms, there are these data visualizations. So this is where you would click to go in and make a plot of whatever data you want to look at. I find this really useful for when I just want to check out, how is the system doing? Is the data coming in looking all right? And maybe I just want to, quickly see some features in our data sets without needing to go and do a full fancy plotting technique. So those are the features of ERDDAP itself. For our Orca buoy data products, we then have multiple levels of data products for every buoy. So here I've instead of clicking the full list, I just did a search for data and I searched for point wells. So this brought up all of the data products that we have for the point wells buoy specifically. And you can see that there's a number of them here. We have 11 different data products for every buoy. Brief rundown of what those different data products are, because I feel like they will appeal to different use cases. So we have our level 1 product. This is sort of our rawest form of the data. This contains every point taken by the CTD package during the cast, including the warm-up and the rise to the surface, the entire thing. It also contains all of the IU standard CORTOD quality control tests, which are performed for every test, every point. For those of you not familiar with CORTOD, it's a series of standardized tests that have been developed by IUs, which can be useful for automating some quality control on the data. And so every single point has a quality control flag associated with it. And you can find all of those in the level 1 product. One of the issues, though, with the profile data is that the samples are just taken at whatever pressure level they happen to be at when the sample is taken. And so what we would like to do is take that data and then grid it onto a uniform pressure grid. So in doing that, we take just the downcast portion of each cast and we put it onto a uniform pressure grid, which makes for easier comparison across different casts. We've done the gridding resolution at different levels. So we have a 1 decibar gridding resolution and a 0.25 decibar gridding resolution. After that, though, we do recognize that for many users, working in depth coordinates would be a more natural frame of reference to work in than pressure gridded. And so we take all of the pressure gridded casts and we convert them into a hydrostatic depth. And then from those hydrostatic depths, we then regrid the data onto uniform depth grids. This is also done at 2 gridding levels, so the 1 meter and the 0.25 meter resolution. After that, we move on to building our climatologies. So we've got 4 different climatologies here. We have 2 for the pressure gridded and 2 for the depth gridded at both of the resolutions that we make all of the data products. The climatologies contain the climatological means and standard deviations for every sensor variable that we have in our data set. However, a climatology is only considered complete if we have at least 6 full years of data over the time period being used. We are using the 2010 to 2022 time period because that's the time period that has uniform coverage across all of our buoys. And so with that extra criteria, we actually only have 3 buoys that we consider a complete climatology. Those are Tuano, Hoodsport, and Car Inlet. We have climatologies for the others, but we do mark them as incomplete. So just to try to get people to take them with a grain of salt. But yeah, we have those products for everything. And then lastly, we have our anomalies. So the anomalies are only done on the depth gridded data. And the anomalies are created simply by taking the day of year of any individual cast and removing the climatological mean for that day of year. And again, we have these at 2 different data resolutions. So after going through that rundown of all the different data products, it can be useful to actually go and look at how we do this. So I'm going to get out of this just go to our website. So this is the Northwest Environmental Moorings website. It's at nwem.apl.washington.edu. And if you're on this website, you can go to our products and down to data request. And we've updated it recently to add access to our ERDDAP. Here you can access the ERDDAP data server. You can also check out a draft of our data manual if you care to look at that. So clicking on the ERDDAP server, this is that same page that I showed you before. We can click a list, and then that brings up all of our different data products. There's 11 data products per buoy. And then we also have some additional data related to some of the other buoys we're working on, which we're working to get up there. But I wanted to show you some of the different ways that you can get the data and the different tools that are on here. So the first thing I usually like to do is click on, I like to graph the data. Click on the graph. We have an automated sort of a default search that we put in where it looks for the last month of data. And this is at the Hoodsport buoy. But if we change this time constraint to be a more a shorter time period, you can zoom in pretty quickly and you're able to look at all of the points for an individual cast. So this is that same thing I was showing before, where it starts at the resting depth, goes up, comes down, and resets. So with this, you can quickly jump between different variables, see what they're doing. If we go to temperature, you can see that the default color bar range isn't really showing us as much detail as we might want to see. So we can, here we can change that color bar range such that it's tighter in on the data set that we're actually interested in using. So now we can see a little bit more detail of what's going on throughout that cast. We have different variables in here. We've got chlorophyll, we've got oxygen, and this is the wrong range, especially this time of year. But I don't need to go through all of these just to highlight some of these different things that you're able to look at. The other pieces that you can do beyond graphing it, I guess I could go back to this. So from this, you can go and look at the data as an HTML table. You can also, go to the data access form here. And this lets you, in a little bit more control, specify all of the variables that you'd be interested in downloading, putting any constraints on it that you may want to see. And I'm just going to do it for the most recent. And yeah, you can, same thing, you can look at an HTML table of all the data. Again, useful if you just want to explore the data a little bit. But then you can go and choose all of these different file types that you might want to download the data as. So if you want a CSV of everything, you click that. It downloads quickly. And then we've got our CSV with all of the data. There's also NetCDF options. There are map files. Yeah, there's a lot of different options in there. Beyond looking at the individual profiles, you can look at the gridded data. So the same thing we were looking at before, but now this is the depth gridded data. And this is something that I usually go in to look at. If I just want to find some data real quick, I can check out the different variables really quickly to see what's going on, see if anything is looking weird that I might need to investigate further. One thing to note here, again, this is sort of highlighting some of the plotting tools or the plotting abilities that you have. You'll notice that the chlorophyll is plotted on a log scale. Maybe you would rather just look at it on a linear scale. In this case, it ends up being, pretty washed out for most of it because it's very low. But you might be interested in just looking at the upper water column, in which case you can change the y-axis range and really zoom in on just that upper feature. Excuse me. We also have our climatologies. Again, just useful to explore. It's kind of nice to be able to see those seasonal cycles pretty quickly just by looking at one of these climatologies. You'll notice in this case that the climatology only goes down to about 90 meters for this particular buoy. Part of the reason for that is while we have a target depth of 120 meters, it hasn't always been that. There are periods when we've sampled to lower depths, or there might have been some buoy malfunction where it didn't always sample down there. And so that piece where I was talking about of having enough data to actually create a climatological mean, we actually didn't have enough data deep down. And so we decided to cut off that climatology. It's at about 90 meters. But again, you can just click through, look at the different variables pretty quickly. And then the last data product that we have are the anomalies. So again, a very nice thing if you want to see what's going on quickly. You can look at this, see, it looks like the water is getting a little bit warmer than normal deep in Hoodsport. Or you can check out how oxygen is doing, that sort of thing. Yeah, so those, I guess the last piece I wanted to highlight was with these features, I didn't really show this before, but you can say, okay, I've made the figure look how I want it to look. I only want it to go a little steep or something, and I would like to save this figure. So you can go down and say, I want a PNG. It makes this figure, and then you can just save it and use this if you need it for whatever purpose. So working with the website is a pretty useful way for exploring the data. It's the primary way that I use when I need to just explore the data real quickly if I'm not looking to actually manipulate or do any calculations with the data, but just if I just want to see what's going on, I usually just go through the website. But sometimes you would like to download the data. And in doing that, this goes back to the piece where I was talking about where if you understand the URLs of the data download, that you can manipulate them and set it up to download any data set that you'd be interested in. So I have, for an example here, is it's just a URL created to download some data from the table down. The URL looks pretty complicated, but once you go in, if you can deconstruct that URL into its separate pieces, you can see what's happening pretty quickly, and you can start to see the pattern, so you can understand how to manipulate the URL to do what you want. So there's the main pieces that you have in this table DAP example are, you've got the base URL, you've got the data type, so in this case, a table DAP. The other option is grid DAP. You've got that data set ID, which is that piece where I showed the title on one side and then data set ID on the right. You have your desired file format, in this case, a CSV. Then you have your selected variables, which are shown in blue, and they're separated by this symbol. And then you have your constraints. So here I'm looking for data that is greater than October 24th, 2023, with a quality control flag less than or equal to 3, meaning questionable data is included, but bad data is excluded. And from this, you can just take this directly and copy it and drop it into a URL, and the data file downloads, and you can open it up and you've got your data. So just an example of how quickly you can go and get some data and download it and ready to work with. If you're not interested in downloading the files directly, there are some other ways to access the data. As I mentioned before, I do recommend checking out this ERDDAP tutorial. But there's also some tools for more direct programming language interfaces. So IUS has been developing a a Python package for ERDDAP, ERDDAP-Py. This allows for you to directly connect to an ERDDAP server, download the data directly into your programming workspace, and manipulate the data that way, without the need to download a netcdf or whatever file type you might be interested in. I haven't used R myself, but there is also a Python a ERDDAP package for R called R ERDDAP. It's very creative naming. And then I believe it is possible in MATLAB. However, I think you need to have the mapping toolbox. I believe it uses a web map server functionality. So I think it's possible, but I haven't tried it myself. Anyway, that is the first app. So we'll open it up for any questions on, how to do this, or if I can clarify anything for you.
Thanks, Seth. Feel free to raise your hand or unmute or put something in the chat, or the Q&A. I have like all the functions enabled that I will check. If you might have a question about, there was a lot to go through there. So maybe there was a question of, do you have this specific variable, or, can I download in this specific format, or I don't know, anything like that. John.
Yeah, hi. Just wanted to mention that, that URL looks pretty complex, but it's very, very powerful if you want to automate anything. If you want to make plots on a regular basis with scripts that you have in Python or MATLAB or whatever, I use that pretty frequently to you can call the data immediately, load it into your environment, and then plot it. You can just have all these scripts that just run in some schedule, and you don't have to interact with that web interface that requires a human. So that's the power in the URL.
Yeah. You can just manipulate, this day, and it'll move to the next day. And yeah, it's really useful. I should mention quickly, I didn't show an example here. The ERDDAP format is a little bit different, but it's the same idea of a URL, type dataset ID. I think it's really just how you set the constraints is different.
There's some great other tips going on in the chat. Question from Christian Saracen. For the depth gridded data, those depths are relative to the surface, correct? And are there any estimates of tidal depth changes on the Orca buoys?
There is not. No, the depths are entirely just calculated assuming a hydrostatic depth. So it's, you take whatever pressure you have, you integrate your potential density profile through that to get that depth. So we're not including anything about, it's not referenced to some mean sea level depth.
From the surface.
Yeah.
Of the tide. Yeah.
Anything else? Is there anything in the...
Dana, getting questions from your crew. Hi, Dana.
Hi there. I did have one question. I noticed that on the climatology on those graph pages, the date shows up as 1970.
Oh, yes. Yeah. That's
a product of something.
Yeah, so that's a great question. So ERDDAP just requires you, if you're going to have a date, you have to have an actual date. But the climatologies just refer to the day of year. And so we have all of our data is referenced to January 1st, 1970. That's just uniform through all of our data sets. And so when you go on ERDDAP, it'll say 1970, but basically disregard the year, just go January 1st, March 30th, whatever you're interested in. And yeah.
Thanks.
Thanks. We've got a question from Fiona Spencer. How quickly is the data available after it's collected? Is there something that happens in between the data uploading to the server and the collection of the data?
Yeah, good question. I'm actually going to get to that in the second half, but as a quick answer, it's about 6 hours from when we do the data collection to when it's available on the server. And the main limitation on that is really how often do we download the data from the buoy. Once we have the files, for it to go from collecting the raw hex file that contains all of the information for each cast to processing, creating the new files, updating our existing files, and then actually refreshing the ERDDAP server, it's about 20 minutes. So it's pretty quick. The data processing itself is, sub 5 minutes, and the ERDDAP is set to refresh itself every 15 minutes. So that's about the time frame that it takes.
Thanks, Seth. From Christopher Krems, are there QC tests to ensure that the pumped variables are not compromised by pump issues leading to vertical misalignment? I assume you use Seabird.
Yes, yes, we do use Seabird, and yes, we do have some QC tests. Again, I'll be getting into some detail on that in the second half. So the core dot tests are pretty useful for checking for things like spikes and, is it outside of some sort of expected range, but we do have some issues where, occasionally we'll get the pump intake will become clogged and the sensors aren't really aligned with what we're actually expecting to be observing. So we do have some tests in there. Those are more internally developed tests. They aren't standardized tests that we're using. But for that specific case, we've developed a test where we check the TS signature of the water properties on the upcast and the downcast portion. And, we would expect that they wouldn't change significantly over the 5 to 10 minutes that it takes to do a cast. And so if we're seeing that the TS signature for the profiles are significantly different, we're assuming that something has gone wrong. And in that case, we flag the entire profile as being problematic. And we just give it a flag of bad and essentially throw it out. The data is still there. We do have all of those profiles are available, but they've just been flagged as bad.
Awesome. Thank you, Seth. Dana, is your hand just up from before? Or do you have another question? Oh, okay. Thanks. Yeah. Feel free to keep putting questions in the chat. We're going to move ahead with the next section. And Seth gave me permission to say this. If you're someone that was only interested in looking at how to access the data, you can feel free to drop off the call if knowing about all of the data processing details is not your main interest. He will not be offended. And we are recording this and we will split it into 2 sections and post it online. So if you want to go back and revisit anything that he said, and like I said in the chat, we will share the slides after the meeting. John, you've got your hand up before we go on.
Yes, before we lose everybody. So Seth and I have been working pretty steadily on this. And so the next phase of this is getting our offshore mooring data on our ERDDAP server. And so it won't be just limited to the Orca. And so we'll have Cheba, which has been out since 2010. And we have our profiling subsurface mooring, which has maybe been out since 2011. Huge amount of data from those 2 moorings as well. And those will all be eventually on the ERDDAP server. So come back, visit, reach out to us, but we're steadily getting those data up there as well.
Yeah, that's great to mention, John. Thanks. Yeah, if you look on there, you see that we already have a couple of data products up there, but there's more to come. So yeah, definitely just reach out if you're curious of, I thought there was supposed to be whatever data, when's it going to be up there? Just let me know and I can at least give you a hint of when we're expecting. But all right.